coordinate geometry in the xy plane, midpoints of lines, and also perpendicular bisectors. So you need to be able to find the midpoint of a line joining 2 points. If the points are x1, y1 and x2, y2, then finding the middle of them is dead easy. You basically add them up and then halve them. So x1 plus x2 divided by 2, y1 plus y2 divided by 2, and you've got the midpoint of a line. Technically, it's a line segment. Lines go on forever. Line segments have a start and an end. So x1, y1 and x2, y2 are the ends of the line segment. So you want to find the middle of the following pairs of points, add them up and halve them. It's as simple as that. 2 plus 6 is 8, half of that is 4, 3 plus 9 is 12, half of that is 6. So you can find the middle by adding them up and halving them. We can do it with algebra, not a problem. Add them up and half them. 2a plus 7a is 9a, so 9 over 2a, minus 4b plus 8b is 4b, so 2b when you halve it. Leave it as a fraction, don't write it as anything stupid like 4.5a, just leave it as 9a over 2. We can do it with surds, it's not a problem. We just add them up, so 4 plus minus 4 divided by 2 is 0. Root 2 plus 3 root 2 is 4 root 2, and 4 root 2 divided by 2 is 2 root 2. So then we can work it out like that. AB is the diameter of a circle, so this is where midpoints are handy, but obviously if you've got a diameter, then the middle is going to be the centre of the circle. So we can do a rough sketch, it's more or less that. There's A is minus 3, 8. There's B is at 5, 4. If we join it up, then the centre of the midpoint is the centre of the circle. So minus 3 plus 5 divided by 2, 8 plus 4 divided by 2, the centre of the circle is 1, 6. If a question says give your answer as coordinates, make sure you give it as coordinates. PQ is the diameter of a circle, centre 2, 2. Given that P is 8 minus 5, find the coordinates of Q. Again, a little sketch is the way forward. There's your circle, centre 2 minus 2. There's P's 8, 5. So write the unknown coordinate in terms of xy and fill in the formula. So we know that Q is going to be x1, y1. So x plus 8 divided by 2 is the middle. Y minus 5, or y plus minus 5 divided by 2 is the other one. And that must equal 2 minus 2. So now you can solve each of those equations. X minus 8 over 2 must equal to 2. So rearranging that, x is minus 4. And y minus 5 over 2 is minus 2. Rearranging that, y is minus 1. We can now do some relatively tricky problems. These are often quite wordy. So the line AB is the diameter of a circle, centre C, where A and B are minus 1, 4 and 5, 2 respectively. Respectively just means they're in the same order, so A is minus 1, 4 and B is 5, 2. The line L passes through C and is perpendicular to AB. Find the equation of L. There's one key rule for these questions, and it is draw a sketch. Every time we do a question like this, draw a sketch. So there's some axes. There's the circle, centre 5, 2. There's A is minus 1, 4. There's B is 5, 2. There's the diameter. There's the line perpendicular to the diameter that goes through the centre, and we want to find the equation of that orange line. So what do we need? We need to find out the gradient of AB. We know a formula for that. We then need to work out the gradient of the perpendicular. We should have learnt that relationship. We also need to find the coordinates of the centre. Well, we've just learnt how to do that. And then we can find the equation of L using the formulas from C1. So the gradient, changing y over to changing x, the gradient is minus 1/3 for the line AB. So given that, we therefore know that the perpendicular must be 3, because remember it's minus 1 over m. To circle, add them up and halve them, is it to be 2, 3, and then finally the equation of L, we can use y minus y1 is m, x minus x1. Using that formula, y1, x1, y1 we have the centre of the circle, m we have the gradient of the perpendicular, substitute in the numbers, and then rearrange it to be y is 3x minus 3. So we have to keep all these formulas in our mind and then be able to use them appropriately. Another wordy question. The line PQ is the chord. Remember, a chord is something that goes on 2 points on the circumference that doesn't go through the centre. Whatever it does go through the centre, it's a diameter. So the line PQ is a chord to the circle, centre minus 3, 5, where P and Q are 5, 4 and 1, 12 respectively. The line L is perpendicular to PQ and bisects it, show it passes through the centre of the circle. Well, first step, draw a sketch. Axis, circle, centre, minus 3, 5. P, 5, 4. Q, 1, 12. Chord, joining them up. Line L, that goes through the middle of the chord. We have to show it goes through the centre of the circle. Let's assume that it does in our sketch. So what do we need to know? We need to know the midpoint of PQ. We need to know the gradient of PQ, and hence the gradient of the perpendicular. We need to find the equation of the line L, and then we need to substitute minus 3, 5 into it to check that the point C is actually on that line. So midpoint of PQ, add them up and halve them, 3a. Gradient of PQ, we're changing x, minus 2, hence the perpendicular is a half. So now we can use the y minus y1 is m, x minus x1 formula, substitute in the point and the gradient, and we get y minus 8 is a half x minus 3. So the equation of the line is y equals 0.5x plus 6.5. And then if we substitute minus 3, 5 into that, we see, does it work? Yes, it does. We get 5 on both sides. So therefore we have shown that the perpendicular bisector of a chord passes through that point centre of the circle. In fact, there's a general and quite handy rule that the perpendicular bisector of any chord always passes through the centre of the circle. Hence, if we have two chords, and we know the coordinates of the chords, then we can find the centre of the circle by constructing two perpendicular bisectors and seeing where they intersect. So that's one way we can find the centre of a circle from some points on the circumference of a circle. The lines AB and CD are chords of a circle. The line y equals 3x minus 11 is the perpendicular bisector of AB. The line y equals minus x minus 1 is the perpendicular sector of CD. Find the coordinates of the centre of the circle. Well, as we just shown, the perpendicular bisector of the chord goes through the centre of the circle. So if we know the equations, we can hence find the centre. Draw a little sketch. There's AB, there's CD, there's the perpendicular bisector of AB, y equals 3x minus 11, there's the perpendicular bisector of CD, minus x minus 1, and where they cross over, that is the centre of the circle. So we need to set the bisectors equal and then solve the equation. So 3x minus 11 must be equal minus x minus 1. Solving that gives us that x is 2.5. Substituting that back into one of the equations gives us that y is minus 3.5. So we can now find the centre of a circle from two chords, because we now know that the perpendicular bisector of the chords cross at the centre of the circle.